Today, we will be looking at simultaneous linear equations. There are two ways to solve simultaneous linear equations: by elimination method and substitution method. Today, we will be looking at elimination method only. In our first example, we have two unknown variables, C and D. For elimination, we eliminate one variable and work out the value of one variable. Let's eliminate one variable. You can decide to eliminate between C and D, but I am going to eliminate C by saying C minus C. C minus C will give me 0. Remember, there is an invincible 1 in front of the variable. So C minus C is 0. 4 minus 6 is negative 2. Negative D, which is negative 1D, minus positive D will give me negative 2D. Now, as you can see here, we only have one unknown variable that we can solve, which makes things easier. The next step is to isolate my variable. So I'm going to move my negative 2 on the other side of the equal sign, and the sign also changes. So I move it this side, it becomes positive 2. The negative 2D stays there. I'm not done yet. I still have to isolate my variable by dividing both sides by negative 2, negative 2. These two cancel out. My D comes down as it is. 2 divided by negative 2 will give you negative 1. So the value of D in this equation is negative 1. Now, let us find C. Since we have the value for D, we can substitute the value of D in any of these two equations. I'm going to substitute it in the first equation, which is C equals to 4 minus D. C equals to 4 minus, the value for D is negative 1. C equals to 4. A negative and a negative will give you a positive 1. So C equals to 4 plus 1 is 5. So the value for C is 5 and the value for D is negative 1. But to be sure, substitute the value of D and C in this equation. Let's see. C is 5, right? 4 minus the value for D minus 1. 5 equals to 4 plus 1 is 5. Alright, so C and D do fit into the first equation. Let's see if it fits into the second equation. C, which is 5, equals to 6 plus negative 1. 5 equals to 6 plus negative 1 is 5. Therefore, the value for C is indeed 5 and the value for D is indeed negative 1. In our second example, we have 4x plus y equals to 37 and 2x minus y equals to 17. The first step is to eliminate a variable. I will choose to eliminate y. Even if you decide to eliminate x first, it's still the same. You'll still get the same answer. But I will try and eliminate both variables. So for this step, I'm going to eliminate y, and in the other step, I will eliminate x, just to show you that you will still get the same answer regardless of which variable you choose to eliminate first. Y and negative y. How can I eliminate this? by adding them together, because positive y plus negative y will give you 0, right? So positive y plus negative y will give you 0. It's not there. 4 plus 2x will give me 6x. We can remove the 0. So 4 plus 2x will give me 6x equals to 37 plus 17 will give me 54. Right, let's isolate this variable by dividing both sides by 6. These two cancel out and the x comes down as it is. 54 divided by 6 is 9. Now, let's find y. By substituting the value of x between these two equations, I will substitute the value of x in this equation. 2x minus y equals to 17. Where there's x, I put 9. 2, 9 minus y equals to 17. 2 times 9, 2 times 9 is 18, minus y equals to 17. Let's isolate this variable. I'm going to move it on the other side of the equal sign. So here I have 18 equals to 17 plus y. Let's still isolate it. So I'm going to move 17 this side. 18 minus 17 equals to y. I decided to move my y this side because I want it to be positive. I always try by all means to make my variable positive. 18 minus 17 will give you positive 1. Y. So the value of y in this equation is 1, and the value of x in this equation is 9. So we eliminated y, right? Now let's see what happens if we had decided to eliminate x first instead of y, to see if we're going to arrive to the same answers. All right, to eliminate x, whether we add or subtract, x won't go away, because 4 minus 2, you're still going to get 2x, and 4 plus 2, you're going to get 6x. So my x is still not eliminated. What you can do is you are going to try and make the coefficients of x the same. I times this entire equation by 2, because the LCM of 4 and 2 is 4. The reason why I'm timesing it by 2 is because I want to make the coefficients of x the same. I want to put a 4 here, so that if I decide to multiply, to subtract, the x will disappear. All right, this first equation comes down as it is. 37. 2 times 2x will give me 4x. 2 times negative y will give me negative 2y. 2 times 17 will give me 34. Now, the coefficients of x are the same. So if I decide to subtract these two, the x's will disappear. So 4 minus 4 is 0. Okay, we don't have to include the 0, but it's just to show you that the x was eliminated. Okay, positive y minus 2 Positive y minus negative 2 is positive 3y. 37 minus 34 is 3. Alright, let me just remove the 0. The 0 is just there to show you that our variable x has been eliminated. So it's 3y equals to 3. Let's isolate our variable y by dividing both sides by 3. They cancel out. So y equals to 3 divided by 3 is 1. This is the value for y. Let's find the value of x. So where there's y, I put 1. Okay, I substitute the value of y between these two equations, right? I'm going to substitute the value of y in this first equation, this one. 4x plus y equals to 37. 4x plus y is 1. 1 equals to 37. I want to isolate my variable, so I'm going to move my 1 the other side of the equal sign. 37, and it becomes negative 1. So 4x equals to 37 minus 1 is 36. We're not done yet. We need to isolate our variable x by dividing both sides by 4. Both sides by 4. These two cancel out. The x comes down as it is. 36 divided by 4 is 9. So the value for x in this equation is 9, and the value for y in this equation is 1. And it's the same answers that we got when we first decided to eliminate the variable y. In our next example, we have p minus q equals to 3 and 4p plus q equals to 17. The first step is to decide which variable you are going to eliminate first. It can either be p or q. I am going to eliminate q. Here we have negative q plus q. How can I eliminate q? Should I add or subtract? I'm going to decide to add, because negative q plus q will give you 0, which means the variable q is eliminated. Negative q plus q is 0. P plus 4p is 5p. 3 plus 17 is 20. Alright, the 0 is just to show that q has been eliminated. So it looks like this. 5p equals to 20. Let's isolate our p variable by dividing both sides by 5. The p comes down as it is. 20 divided by 5 is 4. The value for p is 4. Substitute the value of p in either of these two equations. I will substitute the value of p in the first equation, which is p minus q equals to 3. P is 4. Where there's p, I put 4. 4 minus q equals to 3. I try to keep my variable positive, so I'm going to move it to the other side. 4 equals to 3 plus q. Still, it's not isolated, so I'm going to move my 3 this side. 4 minus 3 equals to q. 4 minus 3 is 1 equals to q. So the value of p is 4 and the value of q is 1. For you to be sure, substitute both these variables in this equation. All right, if either side, if both sides of the equal sign give you the same value, then the answer for P is indeed 4 and the answer for Q is indeed 1. But you have to substitute the value of P and Q in both the equations, not just the first equation. All right. In this next example, we have two unknown variables, y and x. The first step is to decide which variable you are going to eliminate. We have y and x. I am going to eliminate y. Since my coefficients for my variable y are both the same, it should be easy. -3, I'm going to say -3 minus -3. -3 minus -3. Because if I had decided to add -3 plus -3, I would have gotten -6y. So no variable is eliminated there. But if I subtract -3 minus -3, I get 0. Right? So I'm eliminating the variable y, and I decided to subtract this equation from this equation. Right? -3 minus -3 will give me 0. 7 minus 11. 7 minus 11x minus 4x. 15 minus 21, -6. So -3 minus -3 is 0. 7x minus 11x, -4x. 15 minus 21 is -6. Our equation now looks like -4x equals to -6. Let's find the value of x by isolating it, and that is by dividing both sides by -4. These two cancel out. X comes down as it is. -6 divided by -4 is +3/2, or 1.5, or you can decide to put it in mixed fraction form, 1/2. So the value of x is either 3/2, 1.5, or you decide to put it in mixed fraction form. Now let's find the value of y by substituting the value of x between the first equation or the second equation. I will put it in the first equation. -3y plus 7x equals to 15. -3y plus 7, where there's x, you put 3/2. Okay, let me put 1.5, but it's still the same thing. 1.5 equals to 15. All right, -3y. 7 times 1.5 is 21/2 equals to 15. Let's isolate our variable by moving the rest on the other side. I'm going to, okay, this time I will leave my variable as a negative. There's no reason why I'm doing this. I'm just deciding to leave it as a negative. Usually I would move it to the other side so that my variable is positive, but either way, it's just to show you that you're still gonna get the same answer. 15 minus, I move 21/2 the other side of the equal sign. So -3y equals to 15 minus 21/2 is 9. over 2. Let me put it in decimal form. 4.5. So we divide both sides by -3 to isolate our variable. These two cancel out. Y. 4.5 divided by -3 will give you -3 over 2. The value of y is -3 over 2, and the value of x was 3 over 2, positive 3 over 2. In this last example, we have two unknown variables, y and x. The first step is to decide which variable you are going to eliminate. And I have decided to eliminate variable y. So I have to make sure that my coefficients of y are both the same. And in this case, my coefficients 4 and 2 are not the same. So I'm going to find the LCM of 2 and 4, which is 4. So I'm going to divide my first equation by 2 so that my coefficient of y are the same. 2 times 2, 4y. 2 times 5, 10x. 24 times 2 is 48. Then my second equation comes down as it is. 4y plus 3x equals to 20. Now that my coefficients of y are the same, now I can either add or subtract to eliminate my variable y. So I'm going to subtract, because 4 minus 4 is 0, right? 10 minus 3 is 7, plus 7x. 48 minus 20 is 28. It's 7x equals to 28. Next step is to isolate our variable x by dividing both sides by 7. The x comes down as it is. 28 divided by 7 is 4. Alright, value of x is found. Let's find the value of y by substituting the value of x between these two equations. I'm going to substitute the value of x in the second equation, which is here. I always try to substitute my value in the equation that was never modified. What I mean is, this equation is modified because I times it by 2, but this one is not modified. That's why I'm substituting my value for x in the second equation, because it wasn't modified. So always try to substitute your values in the equation that was not modified. But there will come a time when you will have to modify both equations, the first and the second one. All right, you will see that in the tries that I'll leave at the end of the video. So the value of x here is 4. I'm going to substitute this value of x in this in the second equation. 4y plus 3x equals to 20. 4y plus 3, the value of x is 4, equals to 20. 4y, 3 times 4 is 12, equals to 20. Let's isolate our variable y. Since it's already positive, I'll leave it on the side of the equal sign and say 20 minus 12. My sign changes because the 12 moved. 4y equals to 20 minus 12 is 8. The next step is to isolate our variable still. So we divide both sides by 4. These two cancel out, y comes down. 8 divided by 4 is 2. So the value of y is 2 and the value of x is 4. Previous example, I stated that was my last example, but this is my last example because I want to give you a simultaneous equation where you have to modify both equations. What I mean is, let's say you decide to eliminate variable m. You can't really do that because the coefficients of m are not the same, and you can't really decide to eliminate the variable n because the coefficients of n are not the same. So that means that you have to modify both equations. All right. So my aim is to eliminate variable m. So I'll do this by finding the LCM of 5 and 2, which is 10. So what I will do is I will times my first equation by 2 and I'll times my second equation by 5. Just so that my coefficients of m are the same. If you had decided to eliminate variable n, then you find the LCM of 4 and 7. But I'm going to find the LCM of 5 and 2 because I want to eliminate variable m. Let's multiply them out. 5 times 2 is 10m. 2 times negative 4n is negative 8n. And 23 times 2 is 46. 5 times 2, 10m. Negative 7 times 5, negative 35n. And 11 times 5 is 55. Now that my coefficients are the same, I can eliminate variable m by subtracting 10 minus 10m. 10m minus 10m is 0. Negative 8n minus 35n is positive 27n. Negative 8n minus negative 35n is positive 27n. 46 minus 55 is negative 9. 46 minus 55 is negative 9. So this is how it looks like. 27n equals to negative 9. Next step is to divide both sides by negative 9 so we can isolate our variable n. Not negative 9, but we divide both sides by 27. 27. These two cancel out. N comes down as it is. Negative 9 divided by 27 is negative 1 over 3. Okay, now let's find the value of m. So you are going to substitute the value of n, which is negative 1 over 3, in the original equation, not in the modified one. All right, since we modified both our equations, right, which is these two, since we modified them to get these two over here, we are going to substitute the value of n in the original equations before they were modified. So you can substitute negative 1 over 3 in either this first equation or this second equation. I'm going to substitute it in the second equation, in the second original equation, which is this one. 2m minus 7n equals to 11. So where there's n, you put -2, -1 over 3 minus 7, -1 over 3 equals to 11. 2m, -7 times -1 over 3 will give you positive 7 over 3 equals to 11. Let's isolate our variable. 2m equals to 11 minus 7 over 3, because I'm bringing it this side, right? 2m equals to 11 minus 7 over 3 is 26 over 3. Next step is to divide both sides by 2. Divide this by 2. You divide this by 2. Cancel out. The m comes down. 26 over 3 divided by 2 is 13 over 3. Therefore, the value of n is -1 over 3, and the value of m is 13 over 3. And if you want to be sure, substitute n and m in the original two equations, okay? Don't substitute n and m only in the first equation, and if both sides of the equal sign are the same, then it's the correct. No, you have to put m and n in both equations for you to be sure that they are the correct answers. Do try out these equations for practice.